Okay, today we have got an Alinco. This is a DR-119 and it is a VHF FM transceiver, as it says on the front here in nice big friendly letters. Now I've picked this up from eBay, sold as spares and repairs. They're basically saying that it doesn't receive. Probably paid more than I should have done for it, but I thought it'd make an interesting repair video. Yeah, and I think they're quite a handy, quite a nice little 2-meter transceiver. If we turn this thing on, we don't seem to be getting any sound. Now, yeah, it kind of dropped out there. It didn't sound good, did it? I've got the squelch right down, volume right up. I'd expect to be hearing sort of discrimination noise there, you know, but we're not getting anything at all. And they CTCSS, encode, decode. So that might be the problem, but it doesn't appear to be. Yeah, I've never serviced one of these, so this is the first time I've ever been into one. So there's probably people out there who've got more experience with them than I've got. So do please leave comments. I don't know, this could be a common fault. I haven't really done much research on it. One thing I have done is I've managed to find a circuit diagram for this. Now, it's a bit like the Dead Sea Scrolls. Somebody's scanned it, but I'm just grateful that they have. Also, I've managed to find from the Alinco website, it's basically the alignment procedure, which is nice. So I think armed with the schematic and the alignment procedure, we should be okay. Now, if I put the mic on there, you can actually hear it is doing something. So if I put the mic on the speaker, so there is some noise there. The squelch seems to, the busy light comes on and off with the squelch, which I suppose is a good sign. The volume doesn't seem to be doing anything at all. Okay, there's one other thing I've noticed with this. As we're set and receive, we seem to be drawing quite a lot of current. Now, if you look at the back there, apologies for the flashing light on the display, but we're supplying it with 13.7 volts DC from this bench power supply, and we seem to be drawing 760 milliamps, which I think is rather high. I need to check the specification, which I imagine is in the user manual, and I know there is one online. I'm going to go away and check that, and hopefully I should be able to see what it is supposed to be pulling. And I imagine that it should only be about 300 milliamps, or one would have thought so. So the next thing I'm going to do is inject a signal from a signal generator. This is a 2955. It's a Marconi communication test set. I don't know, a lot of people are familiar with these, but you know, we can basically generate signals, we can test transmissions, you know, send the information back into it. So what we're going to do is put this into RX mode, and we are sending in a signal at 145 megahertz on the money, to signal level at minus 93 or thereabouts. We're modulating the signal at 1 kilohertz at a deviation level of 1.75 kilohertz, and that is obviously FM. Now, if we look down at our test subject, I'm not sure if you can see that. Let's see if we can bring that up a touch. Oh, power's coming off. But that's giving us full deflection. We're getting full deflection there. And we should be hearing that audio tone coming out of the speaker on the audio path. But the volume's on full and we're getting not a lot, in fact nothing at all. So there's something on the audio path, and we've got that problem with the overcurrent on receive. So, well, the first thing to do, let's get the thing apart and dig into the service diagram and try and figure out how this thing is working. Okay, so we've got the radio apart. There's a couple of things that are jumping out at me. I don't know if you can see that, but around this area we seem to have a lot of discoloration. This IC is an audio power amplifier, which I think, well, it sounds like it's okay, but we'll have to test. We're going to have to do some tests on it. And I notice this screw head is very discoloured. So that would suggest that we've had capacitors, electrolytic capacitors leaking around here. I've also noticed on the speaker when I removed it, I mean, you can see that on the end. I don't know if it'll focus. You can see it's got a lot of crud on the end of the little Molex type connector there, and that plugs in down there. Other things I've noticed, we've got these little fine wires here which don't seem to be going anywhere. They look like modifications, and we've got a bit of yellow insulation tape, and yeah, two fine wires that they both seem to be going into the front panel. I'm not sure exactly what they're doing. It may be that this was used as a PMR radio. I'm pretty certain you can wideband them, and it may have had some tone control type board. But okay, this is a point of interest. Okay, so I've removed 3 capacitors. We've got 3 electrolytics. They were made by Sanyo. So here you can see they really have discharged their electrolyte, and yeah, that stuff will leak through copper. So I need to clean that up. I'm going to clean this section up too. And here's the 3 capacitors. I don't know if you can see those. There's the 3 I've removed, and if you put them on a tester, I've got quite good LC testers, but this works fine. Yeah, it's supposed to be 1,000 microfarads. It's coming in at 395. And an ESR of 25, well, nearly 26 ohms. We got another one here for those who like to see these things, but they're all low. Now, there's nothing here that's going to stop this thing from working, if you ask me. Oh yeah, that's not looking good. That's supposed to be 470. So that's coming in at 325. Again, ESR is nearly 100 ohms. Yeah, it's supposed to be 470. Yeah, it's all gone low, high ESR. It's what you'd expect if they've done that anyway. So let's have a quick look on the circuit diagram. Okay, so this is our schematic. Now, as you can see, this is a scan. The quality isn't brilliant on here, but it's reasonably legible, and we can kind of figure out, some of the values. So the area of interest, if we look here and zoom in. Okay, so this device here, this is our audio amplifier IC. Well, it's a power amplifier. And basically what this does, this amplifies the audio signals so that, they will actually drive the speaker. And the signals come in at this point, which are coming from this board here. Now that's a switching board, but we'll get back to that in a second. So if we look at this IC, so that's the input on pin 1. I can get rid of that little block. Yeah, so that's the input on pin 1. And we've got the output on between pins 6 and 7, and we can actually look at the data sheet on that. So if I can find the right one, hang on. Yeah, okay, so pin 1, that's the input, and the output is pin 6 and 7, and our VCC, our positive voltage rail, comes in on pin 8. So let's just go back to here, which that's exactly what's happening. So the capacitors that we removed is C93, which is this one. Now that's a 13.8 volt rail. It comes in, we've got a choke and 1000 microfarad capacitor. This is the one that's leaked at 16 volts. Now it's a 16 volt capacitor. It's not a voltage thing. I don't think it's not been over volts. It's the reason it's some capacitors are prone to it. And it's aging. Electrolytics, they're notorious for going wrong. Anybody will tell you that. So that's, if that's gone open, which we know it's gone low value and it's got high SR, that's not going to affect the operation of this. The only thing is, if there's any line noise, it's going to kind of get in here. But we're going to have to replace it, but that's not what the problem is. We've also is C91, which is this one, which is a 470 microfarad, and that's at 10 volts. Now that's very low. Now that's on the output, that's on pin 6 and 7. So that's it's basically a AC coupling capacitor. It's blocking any DC coming out of the IC and only letting the audio signal, because it's alternating, sort of pass through, and that will in turn go to the speaker. Now we had some sound there, so I don't think that's the problem. I'm going to have to put something in there. I don't actually have any 470 microfarad caps, so I'm going to have to put in something. I'm just going to put a 220 25 volts. That's what I've got. I'll order some caps, but I want to get to the bottom of the problem. And the other cap we changed was down here, which is this one, C44, and again that was a 470 at 10 volts. Was that at 10 volts? No. Yes, it was. It is. It's at 10 volts. So what this is doing, it says AV, it's a voltage regulator, and what this is doing, you've got 13.8 volts on this side. Have we got it? Yep, because that's so this is our 13.8 coming in. Obviously the audio amplifier, power amplifier IC is tapping onto that rail, and we also feed in this 8 volt regulator. So on the output of this here, this should be 8 volts. So 10 volts. You could put a 16 in there. I probably will, because they're probably easier to get. But again, that is not going to cause us the problems we've got. So what I'm going to do, I'm going to put this capacitor in, and I'm going to have a look at what's coming in on the input here of this audio amplifier IC. I suspect very little, and then I'm going to start tracing it back up into here. Okay, so I've been busy with the toothbrush and some IPA, isopropyl alcohol, and if you look, you can see I've cleaned all this mess up. It was absolutely everywhere. There was, I don't know what you can see in there, but it was all around the 5 volt regulator. I undid this screw and I cleaned behind here with a fibre brush, and just giving it a big scrub basically. And I've replaced that capacitor. This is the AC coupling capacitor, which comes out of the output. Well, it goes to the output of the audio amplifier, goes through this and then on to the speaker. So yeah, it's
Yeah, and this one, as I said, is a 220 microfarad. I don't think it'll make that much difference, if I'm honest. But the other two caps are out. They don't need to be in at the moment while I'm testing, because most of it's to do with line filtering. So, you know, we are connected onto a very clean DC power supply at the moment. And the 470, it sits on the other side of this 8-volt reg. Yeah, it's probably doing a bit of decoupling. It's just keeping any noises out of other parts of the radio. So they need to be replaced. I'm going to order the parts. So I'm going to put some power on it and let's see what we've got. Okay, so we connected up to the power supply. I've got, we've got it connected up to the 2955, and let's see what is happening. Whoa! So we've got sound, and we've got squelch. How good is that? And I noticed before it was a bit dim, the display, but it's now nice and bright. If anything, it was dim over this side before, but now it's brighter this side than it is that side. Okay, but that is good. Now we're on an extension speaker. And if we look at how much current is drawing, we're now at 400 milliamps, which is nice because it was about 760, was it? So it's about a half of what it was drawing. So I imagine that's probably just the leaking capacitors, because they, when we take them out, we heat them up, with the soldering iron, and they start to reform. So what they're actually doing in circuit, I don't know. And it could well be that the electrolyte was conductive as well. So it could have been that's drawing the current. So the ones I imagine that would cause the problem is the one on the 8-volt regulator, or the, there's one for line filtering, the 1000 microfarad. Okay, so I have tested this on the Marconi, and we are receiving really well. It's producing 12 dB of cyanide plus for minus 23 thereabouts dBm, which is 0.16 of a microvolt into 50 ohms, that is. And yeah, it's going good. Some of the audio sounds, sometimes it can sound a little flaky. We found some capacitors in there. I'm going to replace all the capacitors. Now it's working. I was absolutely sure that that wasn't the problem, but it was, and that I have to eat my words. That's how it goes. I won't edit it out. It all goes in. What you see is what you get. But yeah, it needs capacitors. I mean, you got to remember this thing is probably from the early 90s. So I'd say these capacitors they've lived their life, and they don't last. They're the most single point of failure in equipment, on old equipment, certainly. Okay, there's another thing, is you've got Peter at TRX Lab. Now, I have a great respect for that man. I really love his work, and he's a really good guy with it too. He's a really nice bloke. And there's a thing that he said, which there comes a point when you're not doing repairs, you're not carrying out repairs, you're actually restoring a radio or equipment. And the more I think about it, it's so true. These things are old, through aging, and that's what we're doing. I mean, that's what we're doing here, is dealing with we're dealing with problems that are related to the age of the radio. So it's restoration. That's what it is. And and it's a lot of work. I used to fix modern equipment. I fix modern equipment all day long. So but it there is a difference. You go in, you look for a specific fault, and there may be a couple of faults because one leads to another. But in older equipment, you get quite a few faults because things have aged, and when one thing topples over, you get a bit of a domino effect, and yeah, they go wrong. Okay, so one thing I will say is, if you're new to the channel, you know, please like and subscribe. I don't have that many subscribers, simply, I guess, because I haven't been making videos. So I put a 7-year pause in making videos, but I've come back. So, you know, if you like the content, yeah, please subscribe, because it does help the channel. Okay, so I'm going to leave this video here. I may make another video when I get all the parts, and probably put this on an antenna and see if we can have a QSO with it. So until then, adios.